Okay, students, good morning, everyone. I am Kishore Kumar. So, let's talk about Newton's laws of motion. Today, we are going to discussing about this topic. So, in this topic, we have one term which is called force. Force. So, what is meant by force? So, we are going to use this force every time. So even if it is a problem solving or anything else, so that force is nothing but pull or push a body. So which means a body stop moving the object or tries to stop moving the object or start moving the object or tries to change the shape of the object, whatever it may be. So simply called as pull or push of a body. Okay, so this is tries to change state of object. So which means start moving or stop moving. Start moving or stop moving. So in this lesson we are going to discussing about major three laws. What are those? Newton's first law and Newton's second law and Newton's third law. We know all about Newton's third law. Every action there is an equal and opposite reaction, but we will talk about later. But firstly we are going to discussing about the first law of motion. First law of motion. So what is this statement? What is the first law of motion statement? What it states? So every body there is a body is said to be continuous its state of rest or in state of motion until external force act on this particular object. That's it. Okay, understand? Uh, a body is said to be um, a body is said to be rest or in motion. Rest or in motion. A body is said to be continuous rest or in motion until external force act on it along a straight line. Okay. Along a straight line. This is so. In this first law, we call also law of inertia. Why? Because we will talk about it. Okay. So basically, the thing is law, which is inertia. Inertia is nothing but inability of a body tries to change its state, which means motion or rest, whatever it may be. Okay. In this inertia, we have three. What are those? Inertia of rest, inertia of moving, inertia of direction. What are those? We will discuss. Basically, inertia of rest. Initially, what is inertia? So the inertia is nothing but inability of your body tries to change its state of rest or motion. tries to change its state of rest or motion. So in this regarding we have rest, motion and direction. What are these things? This is nothing but inability of your body tries to change rest. Okay. In this regarding this motion, inability of your body tries to change its motion. Regarding this direction, it is inability of your body tries to change its direction. So whenever we discuss the example, then we will clear it this concept. So rest means whenever you go, whenever you are standing freely on in a bus, the bus is moving constant acceleration, constant velocity. So when driver suddenly brakes, then you will go in forward direction suddenly because of your body already in motion, but your body is you want to be in rest state. So that's why uh, it doesn't change suddenly rest to motion. So meanwhile there is a motion also. Meanwhile there is a direction also. Direction means whenever you travel in a car, so where there is a road in curved shape, so you are going to turn your car, then you will directly, so the car will throw outside of you. So that is the reason direction of inertia of direction. So next we will talk about Newton's second law of motion. So what is Newton's second law of motion? So that Newton's second law of motion is nothing but the rate of change of linear momentum is directly proportional to net external forces. That's it. So we will state that, and we will derive also if what if mass constant and what if velocity constant. We will derive this equation. So Newton's second law of motion. So the Newton's second law of motion is the linear momentum is directly proportional to the rate of change in linear momentum is directly proportional to net external forces. So that we know that momentum is nothing but product of mass into velocity. Okay, then we will substitute here d by dt of m into v. We will differentiate dm by dt into v plus dv by dt into m. If m is constant, if m is constant, then what will we get? This term will be 0. Then so f equals to dv by dt into m. What is meant by dv by dt? Which is called acceleration. So m into a. So f equals to ma. Here we will get like this. So what if v is constant? If v equals to constant, then f equals to this term will be 0. Then dm by dt into v. So we will use this term in rocket propulsion. Okay. Because of there is a variable mass system. Whenever there is a simple example. Whenever you take a balloon, if you fill that balloon with air, then you will throw it into the sky. Then it will go like that and come back down. But slowly it will be losing its masses. So there is a variable mass system. At that time we will use like this. Okay, can you understand or not? Yeah. We will discuss some more example with respect to f equals to ma. Then we will directly go to some JE advanced, some JE aspect problems, polyisms and constraints relations like that. Okay. Yeah. Discussing about few more examples, which is nothing but free body diagram. So before we are going to do free body diagrams, FBD, which means shortcut FBD, free body diagram. So before we are going to conclude this, we will discuss about Newton's third law of motion. So what is meant by Newton's third law of motion? Newton's third law of motion, we all know every action there is equal and opposite reaction. But everybody thinks like if ball is going to in forward direction with respect to wall, and it will be come back again. So with some velocity. So that ball is, if ball is going to in this direction, this is called action, and it will be come back again, it is the reaction. Everybody thinks like so, but that is not true, it's a false. So action and reaction, there is a co-pair forces. Okay, you understand? uh, but action and reactions want different bodies. Okay, which means simply said, if there is a ball hits to the ball. So here hitting the ball at this particular instant. So if I will draw a free ball diagram, this is ball, this is ball, this is ball. Okay, here I am zoom. So at this particular instant, whenever happened the collision, so the normal force acting on this particular ball like this and ball like this. So these two forces act at that instant of time in on different bodies. Okay, there is an action and reaction at the same time happen. That's what we call Newton's third law of motion. Okay. Uh, okay. We will go directly FBD. So what about FBD? So FBD means free body diagrams. We have how to know about these things firstly. What are those? Tension force, weight, friction. We mostly use tension and weight in this chapter. This is without friction. So frictional force, which is after we will give some briefly concluded. So friction, and what about that? Spring force. Okay, normal force, weight, tension, friction, and spring force. These are the main terms about free body diagrams. So then we will talk about weight. Firstly, weight. What's meant by weight? Weight is nothing but so weight is always directly downward direction. Weight is nothing but when I am standing on here on the surface of the earth. So my weight is always acted towards the earth direction, towards the earth. Earth always pulls my weight, so that uh, if there is a surface, then weight will always act like this, downward direction. So that W equals to mass times G. G means acceleration due to gravity. Okay, this is the weight. What about tension? Tension is nothing but pulling force. Always pulling force. Suppose there is a string. Okay. Suppose there is a string which is attached to the rigid mass on wall like this. There is a block. In this string, which is mentioned massless, in this string tension will be generated, which means it always pulling a body. Pulling a body. It always pulling a body like this. This at this point of contact, tension will be upward direction. At this point of contact, tension will be downward direction. So like that. Okay. We will talk about weight, normal force. What about normal force? Uh, so that normal force is nothing but which is always perpendicular to the surface of your body. That's it. If it is a vertical, if it is an inclined plane, then we have to divide the components which is going to perpendicular to the surface of the body. That's it. Normal force always perpendicular to the surface of the body. That's it. Like this is a surface and there is a block. So the normal force acting on this block like this due to surface. So due to block, the normal force acting like this. Okay, if we call N1 and N2, nothing. That's it. Like that only. So friction we will talk about. The friction is nothing but that relative motion. Relative motion which is opposite to the force or whatever it may. So we will do few examples on this particular topic. What are those? Okay, first example, if there is a surface smoothness, there is a two blocks. Okay, this is mass m1 and m2. A force is applying on this direction, so there is an acceleration here. So what is the acceleration of these two blocks and what is the force? They will ask like that. So we will use here the normal force. Like firstly we will take this block m1. This is the force applying on this. In this particular object, another block is m2. So m1 applying a normal force in this direction. m1 applying on m2 normal force in this direction. Here the acceleration same. So we will write some equation. We all know F equals to ma. By using this equation, we will solve force and acceleration. Then we will find it. So this is normal force. This is also normal force acting between the two bodies. So F minus N equals to M1 into A. Net forces, which means F is greater than N. That's why block is moving in this direction. If block is moving in this direction, then we will conclude N is greater than F. Then we will write N minus 1. Okay, that is another case. Firstly, we will solve this. This is the equation number 1. Then F, which means here there is no force, there is only N. So N equals to M to A. We will substitute this value in this equation. M to A equals to M1A. Then F equals to M1 plus M2 into A. Then A equals to F by M1 plus M2. If we will use this formula, then we will find easily. Okay, let's take one example. If mass M1 equals to 2 kg, then mass M2 equals to 6 kg, force equals to 5 newtons applying on these particular blocks. Then what about acceleration? Then you will find and substitute the values. A equals to what is F? 5 by 2 plus 6, 8. 5 by 8 newtons. Sorry, meter per second square. Meter per second square. That's it. Like that only we will solve lots of examples. So now we will directly going to in pulley constraint. Okay, we will solve like that. Okay, let's discussing about pulley sums. How we can solve this pulley sums. Okay, let's take one example. There is a rigid body, rigid support. There is a one pulley. This is mass M1 and this is mass m2. Okay, so what about the question is rising. Firstly, find tension in massless string. Second one, find acceleration. These are the two major questions in this problem. Okay, firstly we will conclude we have to draw free body diagram. Firstly, so weight m1g, this is m2g. So you will take acceleration in any direction. So if I want to make m2 is greater than m1, then what is? So obviously acceleration in downward direction. This is upward direction. Okay, in this pulley there is a massless. Here the tension is like this, pulling force always. Then we will write equations regarding first m1 block and m2 block. First we will write, so tension is upward, so that's why acceleration is upward direction. We will write T minus m1g equals to m1a. Okay, then in this block 2, m2g minus T equals to m2a. So if we want to a, then we will substitute T on this. From equation 1 and 2, we will directly solve this within. How? So T cancel. You will add these two things. 1 plus 2, add. T cancel. So minus m1g plus m2g equals to a into m1 plus m2. Then a equals to m2 minus m1 by m1 plus m2 into g. Whenever you substitute this acceleration in any of these two equations, then you will get tension. You will substitute T minus m1g equals to m1 into what about a? m2 minus m1 by m1 plus m2 into g. Then you will take LCM. So this T equals to, so m1 plus m2 into m1g, m1 m2 minus m1g. So finally 2m1 m2 by m1 plus m2 into g, like this. So if we will solve one example, then we will completely understand what happened in this pulley problems. Okay. Okay. So let's discuss one problem here. Same like this. There is a rigid support. There is a pulley. Mass 2 kg. And this mass 5 kg. What is the tension generated in this string? Or what is the acceleration? Okay. So you will know about. So take G equals to 10 meter per second square. They mentioned in that particular question. So then we will solve. On first object, take like this. We will follow procedure. 2 kg, 2 into G, above the tension T. So you will take tension acceleration here. Okay. Then coming back to 5 kg. 5 kg, this is 5g and this is tension. Here is the acceleration upward direction, here is downward direction. Then write in examples which means write equation T minus 2g equals to 2 into a. Okay. This here 5g minus t equals to 5a. Substitute in here, then you will get acceleration. A equals to like 5 minus 2 by 5 plus 2, 7 into g, 10. So that 3 by 7 into 10, which means 30 by 7 meter per second square. This is acceleration. So that what about tension? Tension T equals to 2 into m1 m2, 5 to 10 by m1 plus m2 into 7 into 10. So what about 20 into 10, 200 by 7 newtons. That's very simple. Like this only we have solved lots of problems. Not only there is a very few concept and very small concept. These are basement of our MSET entrance exams, but not for this is not enough for JEE Mains aspect. We will discussing more and more for that particular JEE Mains or advanced. So so that's it.